Hello students, my name is Professor Muhammad Asim and we are doing AdMath. AdMath for IGCSE students which have syllabus code 0606 and for CIE O level students which have syllabus code 4037. So both kind of students can get equal benefit from this course. Students, in last lecture we did first 5 questions of exercise 12.10. The topic is the practical examples of stationary points. Today we are going to do some more questions of exercise 12.10. But before I start question number 6, first I would suggest all those students who are watching my lecture first time, kindly go to my playlist. There is a folder, name is AdMath. Watch previous lecture of this exercise. Then after watching previous lecture you will have good command on this topic. So let's start question number 6, exercise 12.10. You can see on your screen the diagram shows a window made from a rectangle with base 2r meter and height h meter and a semicircle of radius r meter. The perimeter of the window is 6 meter and the surface area is a square meter or a meter square. Express in terms of h. Very easy. First we have to write the perimeter of the whole diagram. The first side is 2r, the height is h, then the perimeter of semicircle, the full circle perimeter is 2 pi r and the perimeter of semicircle is 2 pi r upon 2, that is pi r, plus this height h as well. Total perimeter is given 6 is equals to 2r plus h, and h is 2h plus pi r. What is the requirement? Show that h in terms of r. It means we have to make h is the subject of the given formula. So 6 is equals to, we have to take common r from these two. So this is 2 plus pi into r plus 2h, then 6, this 2 plus pi into r shift over here, it is minus 2 plus pi into r, 2h, this 2 is multiply over here, this should divide by other side. So 6 upon 2 minus 1 upon 2, 2 plus pi into r is equals to h, and 2 3s are 6, h is equals to 3 minus 1 upon 2, and 2 plus pi can also be write is r into pi plus 2. So this is the answer of part A. We have achieved the goal. H is the subject of the given formula. H is equals to 3 minus 1 upon 2 r into pi plus 2. What is part B? Show that A is equals to 6r minus 2r square minus 1 upon 2 pi r square. What is A? A is the surface area. Means A is the area of rectangle, plus area of semicircle. This is called the area or the surface area. So A is equals to area of rectangle is 2r multiplied by height h, because the formula of the area of rectangle is length into breadth. Length is 2r, breadth is h. Formula of the area of circle is 1 upon 2 pi r square. Now replace this h by the answer of part A, that is A is equals to 2r multiplied by h. H we have gotten minus 3 minus 1 upon 2 r into pi plus 2 and plus half pi r square. Now we have to simplify because we need what? 6r minus 2r square minus half pi r square. A is equals to 2r 3 minus 1 upon 2r into pi is pi r upon 2 and minus plus minus 1 upon 2r into 2 is simply minus r plus half pi r square. A is equals to 2r into 3 is 6r. 2r into pi r, 2 cancel by 2, it is pi r square. 2r into r is minus 2r square plus half pi r square. So A is equals to 6r minus 2r square minus pi r square plus half pi r square is minus 1 upon 2 pi r square, because sign of the bigger number. Is this the requirement? 6r minus 2r square minus 2r square minus 1 upon 2 pi r square minus 1 upon 2 pi r square. 100% correct. Shown. Okay. Now move to part C. What is part C? What is part C? Find dA by dr and d square a by dr square. Very easy. Just find the derivative of area with respect to r. It means r play the role of x. That is, if the derivative of x is 1, therefore the derivative of r is also 1. So 6r derivative is 6 minus half pi r square. R square is 2r. Derivative 2 cancel by 2. It is just minus pi r. Sorry, I forgot to find the derivative of minus 2r square. That is 4r and that is pi r. So this is dA by dr. Okay. Now find 6 minus 4r minus pi r. Now find d square a by dr square. That is the second derivative. 6 derivative is 0, minus 4r derivative is minus 4, and minus pi r derivative is minus pi. This is complete answer of part C. Hope you understand this easy part. Move to part D. Part D is find the value of r for which there is a stationary value of a. Very easy. D part. Just replace dA by dr is 0 is equals to 6 minus 4r minus pi r. So find the value of r, very easy. Minus 4r, okay, wait, 0 is equals to 6, taking r is common, 4 plus pi, then this minus r into 4 plus pi is shift over there, that is r into 4 plus pi is equals to 6, and r is equals to 6 upon 4 plus pi. This is the stationary value of a. The requirement was find the value of r for which there is a stationary value of a. The value of r is 6 upon 4 plus pi. What is the last part? Determine the magnitude and nature of this stationary value. Students, it is very easy. Just take the value of a which we have shown in part B. Look at this, 6r minus 2r square minus 1 upon 2 pi r square. Part E, 6r minus, what is, sorry for this, 6r minus 2r square, 6r minus 2r square minus 1 upon 2 pi r square. But I want to check again, minus 1 upon 2 pi r square or not? Yes, minus 1 upon 2 pi r square. Now put this value r in the value of, in the formula of a, that is 6r. R is 6 upon 4 plus pi minus 2 into r square, that is 6 upon 4 plus pi whole square. Or it is more easy if we take common r throughout the formula. So it will be very easy for us. So if we take common r, it is 6 minus 2r minus 1 upon 2 pi r. Now it is very easy. R is 6 upon 4 plus pi, 6 minus 2 into 6 upon 4 plus pi minus 1 upon 2 pi into 6 upon 4 plus pi. Simplify it. So a is equals to 6 upon 4 plus pi into 6, 2 6 are 12, 12 upon 4 plus pi minus 1 upon 2, 2 3 are 6 minus 3 pi upon 4 plus pi More simplification is required. A is equals to 6 upon 4 plus pi. Taking 4 plus pi is the LCM. So it is 6 into 4 plus pi minus 12 minus 3 pi. Six upon 4 plus pi. 6 4s are 24 plus 6 pi minus 12 minus 3 pi upon 4 plus pi. More simplification. Six upon 4 plus pi. 24 minus 12 is 12 plus 6 pi minus 3 pi is 3 pi upon 4 plus pi is equals to 6 upon 4 plus pi. Taking 3 is common, so it is 4 plus pi upon 4 plus pi. 4 plus pi, 4 plus pi cancel. The final answer is A is equals to 6 3s are 18 upon 4 plus pi. This is the answer of the value of A. What was the question? I want to show the whole question again. Determine the magnitude and nature of this stationary point. So we have find that magnitude of A, that is 18 upon 4 plus pi, and the nature is coming from the second derivative. See this carefully. In part C, the second derivative is negative. Therefore, as second derivative d square y by dx square less than 0 means negative, so it is maximum. This is the full and final answer of question number 6. So question is little bit lengthy, but if your concepts are clear, then question is very easy, and this question is very important according to examination point of view. Come to question number 7. Another interesting question. ABCD is a rectangle with base is 2p units and area is a units square. The point A and B lie on the x-axis, and the points C and D lie on the curve which has equation y is equals to 4 minus x square. Part A. Express BC in terms of P. Very easy. Look at carefully. This is x-axis, this is y-axis, this is y, this is x. So the line lines with the point where the two lines are cut each other is called the origin. So this point is origin. The distance from the origin to A and origin to B, the total distance of AB is 2p. Therefore, the distance of OB to is P, and the distance of OA is also P. It is minus P, but the total distance should be 2p. Okay, so I am not putting minus, not necessary. Okay, I'll putting I put minus sign. Okay, but the total distance is 2p. Now see carefully. This BC, this BC, the coordinates of B must be P comma 0, and the coordinate of C, because the value of X doesn't change, so P minus P comma Y, these are the coordinates. So the distance of BC is P minus P is 0 and Y minus 0 is Y. Therefore the distance of BC is only Y minus 0, that is Y. What is Y? Y is given 4 minus x square, and you know x is P, so this is the answer. So 4 minus P square, the answer of BC. And this is the requirement of part A, because they need express in terms of BC in terms of P. So we have achieved the target. Part B. Show that A is equals to 2p into 4 minus p square. What is A? A is the area of rectangle. So area of rectangle formula is length into width or breadth. Length is 2p, breadth is BC. BC we have find 4 minus p square. So the final answer is A is equals to 2p into 4 minus p square, and this is the requirement shown. Part C. Find the value of p for which A has stationary value. Very easy. Just first we have to simplify A. 2p into 4 is 8p. 2p into p square is 2p cube. Now find dA by dP. 8 minus 2 3 is 6 p square. Replace dA by dP by 0. 8 minus 6p square. Then 6p square is equals to 8. Then p square is equals to 8 upon 6. 2 4s are 2 3s are 4 upon 3. I am checking it again. Kindly wait. Kindly wait. I am checking again. A is equals to 2p into 4 is 8p, and 2p into p square is 2p cube. 8 2 3 is 6 p square. 6p square is equals to 8. 2 4s are 2 3s are. I think there is no mistake, but the answer in the book is not matching with my answer. Answer in the book is 2 root 3 upon 3. It means, wait, I am checking again. Yes, the answer is 100% correct, because we have to take squaring on both sides. So p is equals to square root of 4 is 2 upon root 3, or you can write it 2 upon root 3 can be right 2 root 3 upon 3. Both are same. So answer is 100% correct. This is part C. What is part D? Find this stationary value and determine its nature. Very easy. First, we have to write the value of A again. A is equals to 8p minus 2p cube. 8p, p we have achieved 2 root 3 upon 3 minus 2p cube. 2 into 2 root 3 upon 3 cube. 8 to the 16 root 3 upon 3 minus 2. 2 cube is 8 and root 3 is 3. Root 3 upon 3 cube is 27. 3 9s are 27, and if we take 9 is the LCM, 3 3s are 9, 16 3s are 48 root 3. 9 cancel by 9, 2 8s are 16 root 3. 48 minus 16 is 32 root 3 upon 9. So 32 root 3 upon 9 is the answer. Now we have to find the nature again, the nature of the value of A. So dA by dP we have find 8 minus 6p square, then the double derivative dA by d square A by dP square is equals to 8 derivative is 0, minus 6p square is minus 12p, and satisfy this value. Second derivative value is the value of p, that is minus 12. P we have find 2 root 3 upon 3. 3 4s are 12. Minus 4 2s are minus 8 root 3, which is less than 0. It is maximum, because less than 0 means negative. Therefore the if second derivative is negative, the value is maximum, otherwise it is minimum. So hope you enjoyed this question also. A very important question, examination point of view. Move to question number 8. Question number 8 is: a solid cylinder has radius r centimeter and height h centimeter. The volume of this cylinder is 250 pi. V is equals to 250 pi cm cube, and the surface area is a centimeter square. Part A, express h in terms of r. Very easy. The formula of the volume of cylinder is pi r square h. The volume is given 250 pi is equals to pi r square h. Pi cancel by pi. Therefore h is equals to 250 upon r square. This is the final answer of part A. Move to part B. Show that A is equals to 2 pi r square plus 500 pi upon r. The formula of the area of cylinder is 2 pi r square plus 2 pi rh. So 2 pi r square plus 2 pi rh is 250 upon r square. The final answer is A is equals to 2 pi r square plus r cancel by its square. 2 into 250 is 500 pi upon r. Shown. This is the requirement of part B. Part C is find the value of r for which there is stationary value of A. Very easy. Just find the derivative of A with respect to r. 2 pi r square derivative is 4 pi r and 50 pi upon r derivative is minus 500 pi upon r square. Replace dA by dr by 0. 4 pi r minus 500 pi r square. 0 is equals to taking the LCM of r square. So it is 4 pi r cube minus 500 pi. So r square must be multiplied by 0. So it is 0. And now 4 pi r cube r cube minus 500 pi. So 500 pi is equals to 4 pi r cube. Pi cancel by pi. And r cube is equals to 500 upon 4 is, I think, 125. Taking cube root of r, cube root of 125 is 5. This is the final answer. Sorry, I forgot to find part C. Part C is find the value of the derivative of A by dr and d square by dr square. And I have find part D. Sorry for this, but no issue. Part A, part C and part D are almost same. So r is 5. And part C is to find the derivative dA by dr we have already find, but d square by A by dr square is what? 4 pi r derivative is 4 pi and minus 500 minus plus 1000 pi upon r cube. This is the second derivative, 4 pi plus 1000 pi upon r cube. So we have done part C and part D as well. What is next? Determine the magnitude and nature of this stationary value. Very easy. Part E. What is A? We have find 2 pi r square plus 500 pi upon r. A is equals to 2 pi r. R we have find 5 square. 500 pi upon r is 5. So A is equals to 5 square, 25 to the 50 pi plus 5 ones are 5, 100. 100 pi. A is equals to 100 plus 50 is 150 pi. This is the final answer. 150 pi. And now it's a time to find the nature. Very easy. We have already find the second derivative, d square a by dr square. 4 pi plus 1000 pi upon r cube. R is 5, 5 cube. If you see carefully, the whole answer is greater than 0. That is positive. Hence, it is minimum, because if the double derivative is greater than 0, then the value is minimum. So this is question number 8. Move to question number 9. Question number 9 is, the diagram shows a solid formed by joining a hemisphere of radius r centimeter to a cylinder of radius r centimeter and height h centimeter. The surface area of the solid is 288 pi centimeter square and the volume is v centimeter cube. Express h in terms of r. Very easy. First, we have to find the surface area of this solid. Surface area is the area. First, we have to find the area of the base, that is pi r square. Then curved surface area of cylinder is 2 pi r h. Then find the area of this hemisphere. The full sphere is 4 pi r square. Therefore, the hemisphere is 1 upon 2 pi r square. Surface area is given 288 pi is equals to pi r square plus 2 pi r h plus 2 to the 4, 2 pi r square. Then 288 pi is equals to pi r square plus 2 pi r square is 3 pi r square plus 2 pi r h. 288 pi is equals to, take common, taking common is pi r. No, just taking common pi, 3r square plus 2rh. Pi cancel by pi. So 288 and this 3r square shift over here is equals to 2rh. Then h is equals to 288 upon 2r minus 3r square upon 2r. 2 1s are 2, 4s are 2, 4s are 144 upon r minus 3 upon 2. R cancel by its square, r. Answer. This is the requirement. Express h in terms of r. H is equals to 144 upon r minus 3 upon 2r. Move to next part. Show that v is equals to 144 pi r minus 5 upon 6 pi r cube. Very easy. First, write down the formula of the volume of cylinder, that is pi r square h. Then write down the formula of the volume of 4 upon 3 pi r cube. This is the formula of the volume of the hemisphere. Pi r square h, which we have find from part A, plus 1 upon 2 to the 4, 2 upon 3 pi r cube. Kindly ignore this. Sometime I make different shapes, different r shapes. So r is same throughout the question. Now multiply pi r square by 144 upon r. So it is 144. R cancelled by r square is only 144 pi r. Pi r square multiplied by 3 upon 2 r, it is 3 upon 2 pi r square plus 2 upon 3 pi r cube. So V is equals to 144 pi r, 3 upon 2 minus 2 upon 3. Taking the LCM of 2 and 3 is 6. So 2 3 is a 6, 3 is a 9 pi r square plus 3 to the 6, 2 to the 4 pi r, pi r square into 3 upon 2, it should be pi r cube. Okay, so 9 pi r cube plus 4 pi r cube. Therefore V is equals to 144 pi r minus 9 plus 4 is minus 5 pi, again I forgot, this is r cube upon 6. I want to check what is the requirement of the question. 144 pi r minus 5 upon 6 pi r cube. 100% correct. 100% correct. Credit goes to me. Yes. Part C. Find the exact value of r such that V is maximum. Very easy. Just find the derivative of V with respect to r. dV by dr is equals to 144 pi minus 5, 3 5s are 15, 15 pi r square upon 6. Then 144 pi minus 3 5s are 3 2s are 5.2 pi r square replace dV by dr by 0, taking pi is common. 144 minus 5 upon 2 r square, this pi must be divided by 0, and this is equals to 144 minus 5 upon 2 r square, then plus 5 upon 2 r square is equals to 144. 144 into 2 is 288 upon 5. Now taking the square root of 288 upon 5, upon 5 square root is 12 root 10 upon 5. This is our final answer. This is the requirement because they need exact answer, not the answer in decimal. Now move to next question. A piece of wire of length 50 centimeter is cut into two pieces. One piece is bent to make a square. Okay, I am making a square, a rough square. Kindly, if not accurate, looks accurate, ignore it. And other is bent to form a circle. Radius r and length is x. The total area enclosed by the two shapes is a centimeter square. Express r in terms of x. Very easy question. Part A. The perimeter of the square is 4x and the perimeter of circle is 2 pi r. Perimeter is given 50, 4x, 2 pi r. Therefore 2 pi r is 50 minus 4x and r is equals to 50 upon 2 pi minus 4x upon 2 pi. R is equals to 225 za, so 25 and 2 2 za 4. 25 minus 2x upon pi. This is the final answer of part A. Move to part B. Show that the area is A is equals to pi plus r x square minus 100x plus 625 upon pi. Very easy. Area of square is x square and area of circle is pi r square. So A is equals to x square pi. R is 25 minus 2x upon pi whole square. So area is equals to x square plus pi, and 25 minus 2x whole square can be expanded by a minus b whole square formula. 625 minus 225, the 50 to the 100 x plus 4x square upon pi square. Pi cancel by its square, so area is equals to x square plus 625 minus 100x plus 4x square upon pi. Take the LCM of pi. Pi into x square is pi x square plus pi cancel by pi, 625 minus 100x plus 4x square. Next, A is equals to pi x square 4x square. Common is x square, so it is pi plus 4 x square plus 625 minus 100x upon pi. I think this is the requirement. Check this. Pi plus 4x square minus 100x plus 625 upon pi. 100% correct. What is part C? Find the stationary value of A and the value of x for which this occurs. Very easy. First we have to find dA by dx. So 2x pi plus 4 plus 0 minus 100 upon pi is equals to 2x into pi plus 4 minus 100 upon pi. Replace dA by dx by 0. 2x into 4 plus pi minus 100 upon pi. This pi should be multiplied by 0. It is 0. And 100 must be shift over there. Is equals to 2x 4 plus pi. 250 is a, and then x into 4 plus pi is equals to 50, and x is equals to 50 upon 4 plus pi. What is the final answer? $7.00. You can check from your calculator. And now put this value of x in the value of a. What is a? First we have to write the value of a. Pi plus 4 x square 625 minus 100x upon pi. We have find the value of x, that is 7. So pi plus 4 into 7 square plus 625 minus 100 to 7 upon pi. You have scientific calculator to find the final answer with the help of your calculator. The final answer is 87.5, correct to 1 decimal place. And this is the final answer of question number 10. I hope you completely understand this question. Today we are going to do very important questions according to examination point of view. Last question. The diagram shows a solid cylinder of radius r centimeter and height 2h centimeter cut from a solid sphere of radius 5 centimeter. The volume of the cylinder is v centimeter cube. Express r in terms of h. Very easy. If you see carefully, this point, from this point to this point, the value is 2h, and if we drop the perpendicular, this value must be h. So for part A, if we use the Pythagoras theorem, that is the square of the hypotenuse is equals to the sum of the square of other two sides. So r square is equals to 5 square minus h square. So r is equals to 5 square is 25, h square is h, and square root on both sides. So this is the answer of part A. R is equals to 25 minus h square root. Part B, show that the volume of 2 pi h into 2 pi 25 minus h square. The formula of the volume of cylinder is pi r square h. V is equals to pi r, we have find 25 minus h square root square into h. The height of cylinder is 2h. So V is equals to 2 pi h, square and root cancel, 25 minus h square shown. Part C, find the value of h for which there is a stationary value of a. Very easy. First simplify is 2 pi h into 25 is 50 pi h. 2 pi h into h square is 2 pi h cube. Now find dv by dh. It is 50 pi minus 2 3 is 6 pi h square. Replace dv by dh by 0. Taking common is 2 pi. So it is 25 minus 3 h square. 2 pi must be divided by 0. It is 0. 25 minus 3h square. So 3h square is equals to 25. H square is equals to 25 upon 3. Taking square root on both sides. 25 square root is 5. Square root of 3 is 3. Or you can write is 5 root 3 upon 3. Both are same. So what was the question? Find the value of s for which there is a stationary value of v. Yes, we have achieved the goal. Determine the nature of this stationary value. So for nature, we have to find the double derivative. This is a single derivative. The double derivative is d square v by dh square. 50 pi derivative is 50 pi derivative is 0. 6 pi h square is 12 pi h. So minus 12 pi h. H is 5 root 3 upon 3 is equals to 3 4s are 12. So minus 4 pi into 5 root 3 minus 4 into 5 is minus 20 pi root 3, which is less than 0, negative, hence it is maximum. And this is question number 11. What next? Nothing. What is next exercise in this chapter? Nothing. So very good news for you people that today we have not only finished exercise 12.10 but also finished the whole chapter number 12 from exercise 12.1 to 12.10. I did each and every question from each and every exercise, and each and every part as well. So I am showing that I am a very hard working teacher. Now it's your turn. You have to show that you are also a very hard working students. How it is proof? By doing practice more and more and more. What should be our next chapter? Chapter number 13, vector. No, vector is very important, but we will not do vector after chapter number 12, because we have just done chapter number 12, that is differentiation. So why I shouldn't start this chapter, that is chapter number 13. What is the name of the chapter? You can see on your screen. Sorry, chapter number 14, differentiation 2. So our next class consists of this chapter, chapter number 14, called differentiation 2. How many exercises? 14.1. I think it's a small chapter as compared to chapter number 12. 14.2, 14.3, 14.4. Yes, so it has only 4 exercises, and chapter number 12 has 10 long exercises. So our next lecture will be on differentiation 2, chapter number 14. Hope you enjoyed today's class. If you feel any difficulty, any problem, let me inform. Write in comment box, I will help you. And if you think that I am doing hard working for you and my lectures are helping you, kindly do subscribe my channel, and whenever you subscribe, don't forget to press the bell icon button, so that when I upload my videos you will get the notification. Kindly share my videos, my lectures, as many as you can. Okay students, good luck for next lecture.